Hello smart civil engineers. I'm Engineer Masroor and you are watching Engineering Network YouTube channel. I'm back with another important topic. So in today's video, our topic is how to calculate the quantity of materials and beam of a house. Okay. Also, I will find out the number of cement bags, number of sand trucks, number of aggregate trucks, and also the total amount of steel used in the construction of beam. So this is basically the fourth part of complete house estimation course. So kindly watch this video till the end for better understanding. And also you will get the complete course of house estimation in the I button. Now actually in today's video, I have more than one beam, okay? And I'm going to show you how to calculate the quantity of materials for multiple beams in a house. So before I start this very important video, I have a request from you guys. So if you find this video informative, then please like this video, share it with your friends, and if you are new to my channel, then please click on the subscribe button and also make sure to press the bell icon for more civil engineering videos. Okay, so in today's video, our topic is how to calculate the quantity of materials in a beam for a house. Okay, now in the previous video of complete house estimation course, I have briefly explained about how to calculate the quantity of materials for columns in a house. Okay, so kindly watch that video on my YouTube channel. Now before I start to calculate the quantity of materials for a beam in a house, first I have to identify the beams and total number of beams in a particular house. Okay, so if you look closely to the plan of this house, you can see that I have three types of beams, right? So the first type of beam is in the square shape, and it is provided along these three walls, right? And let's say we call this beam is B1. So as you can see, one B1 beam is provided along the full length of this wall. One B1 beam is provided along this wall. One B1 beam is provided along this wall, right? Also the size of B1 beam is 12 inches by 12 inches, which means that the width and height of B1 beam is 12 inches. Okay. Now the length of B1 beam is equal to length of these two rooms, which is 18 feet each, plus width of these three walls, which is 9 inches each, and it is equal to 0.75 feet. So the total length of B1 beam is equal to 38.25 feet. Next is the second type of beam, which is provided along this wall, right? Now let's name this beam is B2. So if you look at here, B2 beam is started from this point and it goes all the way to this column, right? Now you must be thinking that why B2 beam is extended to this column, right? Well, the reason is if you look at the length of the living room, it is 36 feet. And let's say if I remove this beam from here, then what will happen is the slab of the living room, whose span length is going to be 36 feet, will get deflected. Okay? So in order to avoid this deflection of the slab, this B2 beam is extended up to this column, right? Now I hope you will understand this point. And still if you have any confusion, then you can ask me in the comment section. Now the shape of B2 beam is rectangular and its size is 15 inches by 12 inches, which means that the width of B2 beam is 15 inches and the height of B2 beam is 12 inches. Okay? Also the length of B2 beam is equal to width of this room, which is 14 feet, plus width of the living room, which is equal to 14 feet, plus width of these three walls, which is 9 inches, and 9 inches is equal to 0.75 feet. Okay. So the total length of B2 beam is equal to 30.25 feet. Next is the third type of beam, which is placed along these two walls, right? And let's name this beam as B3. So if you look closely here, the B3 beam is placed along the full length of these two walls. Okay. Also, B3 beam is in square shape and its size is 12 inches by 12 inches, which means that the width and height of B3 beam is 12 inches, right? Now the length of B3 beam will be same as the length of B2 beam, because if you look at the plan of the house, both B2 and B3 beams are placed in the same direction. Okay. So the length of B3 beam is equal to 30.25 feet. Now this is all about the position and placement of beams in this particular house. Now let's start calculating the quantity of materials for these 6 beams. Okay. So at number 1 is the quantity of B1 beam. So the volume of B1 beam is equal to number of beams into length into breadth into height. Here number of B1 beams are 3. Length of B1 beam is 38.25 feet. Width of B1 beam is 12 inches and 12 inches is equal to 1 feet. And height of B1 beam is also 1 feet. Okay. So the volume of 3 B1 beams is equal to 3 multiplied by 38.25 multiplied by 1 multiplied by 1, and the total volume of 3 B1 beams is equal to 114.75 cubic feet. Okay. Now this is the wet volume of 3 B1 beams, right? Next is the volume of B2 beam. So the volume of B2 beam is equal to number of beams into length into breadth into height. Here the total number of B2 beams are 1. Length of B2 beam is 30.25 feet. Width of B2 beam is 15 inches, which is equal to 1.25 feet. And the height of B2 beam is 12 inches, which is equal to 1 feet. Okay. So the total volume of B2 beam is equal to 1 multiplied by 30.25 multiplied by 1.25 multiplied by 1. And the total volume of B2 beam will become 45.375 cubic feet. Okay. Also this is the wet volume of B2 beam. Next is the volume of B3 beam. So the volume of B3 beam is equal to number of beams into length into breadth into height. Here the total number of B3 beams are 2. Length of B3 beams is 30.25 feet. Width of B3 beam is 12 inches, which is equal to 1 feet. And also the height of B3 beam is 1 feet as well. Okay. So the volume of 2 B3 beams is equal to 2 multiplied by 30.25 multiplied by 1 multiplied by 1. And the total volume of 2 B3 beams will become 60.5 cubic feet. Okay. Now this is the wet volume of 2 B3 beams. Now I have find out the wet volume of B1, B2 and B3 beams. Okay. And now I need to calculate the total wet volume of these 6 beams, right? So the total wet volume of 6 beams is equal to wet volume of B1 beam, which is 114.75 cubic feet, plus wet volume of B2 beam, which is 45.375 cubic feet, plus wet volume of B3 beam, which is equal to 60.5 cubic feet. And the total wet volume of 6 beams will become 220.625 cubic feet. Okay. So the total weight volume of these 6 beams is 220.625 cubic feet. Now in order to calculate the quantity of cement, sand, aggregate and steel for these 6 beams, I will need the total dry volume of these 6 beams. And also I will need the information about the grade of concrete as well. Okay? So first let's calculate the total dry volume of these 6 beams. So the dry volume of concrete is equal to 1.54 times the wet volume. Here the total wet volume of these 6 beams is 220.625 cubic feet. So the dry volume of concrete is equal to 1.54 multiplied by 220.625 cubic feet. And the total dry volume of 6 beams will become 339.76 cubic feet. So the total dry volume of these 6 beams is 339.76 cubic feet, right? Next is the information about the grade of concrete, that which grade of concrete is used and what are the mix ratio of that concrete grade. Okay? So in these 6 beams, M20 grade concrete is used and the mix ratio of M20 grade concrete is 1:1.5:3, right? So now I am ready to finally start calculating the quantity of cement, sand, aggregate and steel for these 6 beams. Okay? So first is the quantity of cement. So the volume of cement is equal to 1, which is the ratio of cement in the mix ratio of M20 grade concrete, multiplied by the total dry volume of 6 beams, which is 339.76 cubic feet, divided by 5.5, which is the sum of ratio. Okay? And the total volume of cement will become 61.775 cubic feet, right? Now in order to find out the number of cement bags, I will need the volume of single cement bag. Okay? So the volume of one cement bag is 1.25 cubic feet, right? Now the total number of cement bags is equal to total volume of cement, which is 61.775 cubic feet, divided by 1.25 cubic feet. And the total number of cement bags will become 50 cement bags. Okay? So now I can say that in the construction of these 6 beams, 50 cement bags will be used, right? Next is the quantity of sand. So the volume of sand is equal to 1.5, which is the ratio of sand, multiplied by 339.76 cubic feet, divided by 5.5. And the total volume of sand is equal to 92.66 cubic feet. Okay? Now for the number of sand trucks, I have the volume of single truck, which is 120 cubic feet. So the total number of sand trucks is equal to volume of sand, which is 92.66 cubic feet, divided by the volume of one truck, which is 120 cubic feet. And the total number of sand trucks will become 0.772 trucks. Okay? So now I can say that in the construction of these 6 beams, I will need 0.776 sand trucks. Okay? Next is the quantity of aggregate. So the volume of aggregate is equal to 3, which is the ratio of aggregate, multiplied by 339.76 cubic feet, divided by 5.5. And the total volume of aggregate is equal to 185.32 cubic feet. Okay? Now for the number of aggregate trucks, I have the volume of single truck, which is 120 cubic feet. So the total number of aggregate trucks is equal to volume of aggregate, which is 180.32 cubic feet, divide by the volume of one truck, which is 120 cubic feet. And the total number of aggregate trucks will become 1.544 trucks. Okay. So now I can say that in the construction of these 6 beams, I will need 1.544 aggregate trucks, right? Next is the quantity of steel. Now for the quantity of steel, I will need the total weight volume of these 6 beams, okay? And the total weight volume of these 6 beams is equal to 220.625 cubic feet. Now I have to convert the weight volume of these 6 beams from cubic feet to cubic meter, okay? Because the density of steel is in cubic meter, which is equal to 7850 kg per cubic meter, okay? So in order to calculate the amount of steel in these 6 beams, I have to convert the weight volume of these 6 beams from cubic feet to cubic meter, right? So we know that 1 cubic meter is equal to 35.31 cubic feet, okay? So the weight volume of these 6 beams in cubic meter is equal to total weight volume of these 6 beams in cubic feet, which is 220.625 cubic feet, divided by 35.31, and the total weight volume of these 6 beams in cubic meter is equal to 6.248 cubic meter. Okay. Now here I will use a thumb rule for the estimation of steel and beam. So according to the thumb rule, it states that 2% steel is used in beam with the weight volume of beam. Okay. So the quantity of steel is equal to 2 divided by 100 multiplied by the weight volume of beams in cubic meter, which is 6.248 cubic meter. And the total quantity of steel is equal to 0.1249 cubic meter, right? Now I have to convert the quantity of steel to kg and tons. So the amount of steel is equal to quantity of steel, which is 0.1249, multiplied by the density of steel, which is 7850 kg per cubic meter. And the total amount of steel is equal to 980 kg. Okay. Also we know that 1 ton is equal to 1000 kg. So the total amount of steel is equal to 980 divided by 1000, and the final amount of steel in these 6 beams is equal to 0.98 tons. So now I can say that in these 6 beams I will need 0.98 tons steel, right? So this is how you can easily calculate the quantity of materials in beams in a house, right? So in this video, I have briefly explained how to calculate the quantity of materials for beam, number of cement bags in beams, number of sand trucks, number of aggregate trucks, and also the amount of steel and tons which will be used in the construction of these 6 beams. Okay. So I have done all this hard work only to make you guys understand an easy and simple way as possible. And in the return, I'm only asking for, if you find this video informative, then please like this video, share it with your friends, and if you are new to my channel, then please click on the subscribe button, and also make sure to press the bell icon as well, so that you will never miss a notification whenever I upload a new video. See you in the next video.